Hey guys, let's talk about transformations of function families. We're going to look at two function families, a quadratic function. It's y equals x squared, and then over here, y equals 2 to the x. All right, so let's talk about transformations. Transformations just means moving it around. That it's most basic for. That's what we're saying here. So let's say that we want to move this parabola up 3 units. Well, we're going to take the parent function, the original, the OG, and we're going to hit a +3 there at the end. So +3 moves it up 3. Pretty straightforward, right? So I wonder what we could do to this exponential to move it up 3. It works in the same way when you're moving up or down on the graph, on the coordinate plane. So this is called a vertical transformation. It's a translation. So translation, the SL in the middle makes you remember that it's a slide. It's just sliding up. But if we want to slide down, we just change it to a -3. So now notice that the blue graphs have gone down 3 from the original red ones, right? And the number doesn't matter. If we want to move down 5, we change it to a 5. And as long as there's a minus sign in front of that 5, then it's going to move down 5, right? So you can play with that on Desmos as well and just kind of see how that works. All right, let's go back to the original, the parent function, and let's move this left or right. If I think I want to move to the right 5, to me that seems like I should do x plus 5, right? It just seems like it. So let's do +5. Oh, look at that green function. It did not move right 5 like I expected. It went left 5. So left and right, and it's going to do the opposite of what I expect. Okay, so that's important. In parentheses, does the opposite. So here I'm going to change the x value. So I want the x to go left 5. Well, I'm going to do the opposite again and put +5. So now it has slid over, translated, right? And so we can see like at -5, 1, and then 0, 1 here. So it went left 5. All right. So the opposite of what I expect. All right. So let's say we want to go right 2. Okay. So right means opposite of what I expect. Instead of plus, that should be a minus, and then 2. So -2. Yep. The green one went to the right 2 units. So let's do the same thing over here. I want to go right 2. So I need to do the opposite. So -2. The green one went right 2. Now, let's talk about something called reflection over the x-axis. And so when I want to reflect, I just need a negative sign after the equal sign. And notice what it did. It took all the points in that parabola and it flipped them down. It flipped them across that x-axis. And if I want to do that with exponentials, I am, again, just need a negative after the equal sign. That's a reflection over the x-axis. Let's talk for a moment about a vertical stretch. So we want to stretch this by a factor of 4. Now look at this new function. See how much it's taken the original. It's kind of like a typical U shape, and it stretched it towards the y-axis. So it's like pulled it up. So let's multiply this one. So we stretched it by a factor of 4. Notice that it rose up on the y-axis. Let's let it fall down towards the x-axis. We would call that a vertical shrink, or some teachers call it a vertical compression. And there we go. Okay, so we've done the same shrink, the same vertical compression, and notice that it's, instead of pulling it up to the y-axis, it's dragging it down to the x-axis. Okay, so the fraction less than 1 is going to shrink it down. So I think that most of these are like logical and make sense, and then the horizontal shifts, I'm just going to say, it's the opposite of what you expect. Left is positive, right's negative. So if you keep that straight, hopefully you're good. Have a great rest of your day.